Okay, so today we're going to be dealing with back titrations. It's another request from one of the students. Okay, so the question is, this question is about the reactions of calcium compounds. A pure solid is thought to be calcium hydroxide. The solid can be identified from its relative formula mass. The relative formula mass can be determined experimentally by reacting a measured mass of the pure solid with an excess of hydrochloric acid. The equation for this reaction is blah blah blah. The unreacted acid can be determined by titration with a standard sodium hydroxide solution. So as soon as I'm thinking, okay, the unreacted, so they're titrating the unreacted reagent, it's obviously a back titration. Okay, now I'll come to the rest of the question in a second, but okay, the normal titration is when you have your unknown analyte and you literally titrate it. In fact, let me just draw it. So you normally have an unknown analyte, you put it in your conical flask, okay, and you titrate it, okay, with something. So you have your unknown, you titrate it here with some known, and what happens is, based on the sort of the volume that you need, and you know the concentration of the known, you can work out the moles of the unknown. However, the back titration is ever so slightly different, because what happens is you have your reagent, your unknown, that you're trying to find something of. So for example, you could be trying to find the concentration of that, or you could be trying to find out the water of crystallization of that, or anything. So this is the unknown that you're trying to find. But what you do is you take an extra reagent, you take a reagent and you react it with that, but you must have this reagent in excess, right? So what that means is some of that reagent will react with the unknown, but what happens is some of this will remain. And so you take this excess to the reagent that hasn't reacted, and you react it with a second reagent. Now this reagent, you must select something that reacts both with A and C in this case. Okay, so this reagent is key. Okay, but what you do is, once you've reacted it with the first reagent, whatever's left, what you do then is the extra, you titrate it with a second reagent. The fact that you're titrating the excess, what's left, is why it's called a back titration. Okay, you're not titrating this B with A directly and finding out the A. No, you're reacting B with A. Okay, whatever's not reacted, whatever's left, you're titrating that then with something else, and that's why it's called a back titration. Normal titration, direct titration here. Back titration is extra. Okay, so whatever remains, you titrate that with the C. So that's the difference between sort of a back titration and normal titration. Coming back to the question, the fact that it says, oh, the unreacted acid can then be determined by titration, that's why I immediately think, okay, it's back titration. Now, you don't really need to know the fact that it's the back titration. However, this question could have mentioned back titration. Okay, it could have said, oh, this is a back titration. So I don't want students to start sort of being confused about what back titration is. It's just a normal titration, except this time you're titrating the extra thing that's left. Okay, you're not titrating the original A and B, you're titrating the extra B that's left with a separate reagent. But the normal, in terms of calculations, etc., it's very similar, as you'll see. Okay, so the unreacted acid can then be determined by titration with a standard sodium hydroxide solution. You are provided with 50 centimeters cubed of 0.2 molar hydrochloric acid, outline giving brief practical details how you would conduct an experiment to calculate accurately the relative formula mass of the solid using this method. So obviously they've told me how much I must use the hydrochloric acid. Okay, so they've told me that. Brief practical details. So obviously this question is not entirely calculation based. You know, they want you to tell them how to do the practical, yeah, as well. Not just calculate how to use the calculations, but how to use the practical, and that's why it's worth 8 marks there. How you would conduct an experiment to calculate accurately the relative formula mass of the solid. So we need to work out the relative formula mass of the solid using this method. All right, so a pure solid is thought to be calcium hydroxide. Is thought to be calcium hydroxide. The solid, okay. The solid can be identified from its formula mass. The relative formula mass can be determined experimentally. Okay, so now this is 8 marker. This is what you call what they call an extended response type question. So in other words, your response has to be sort of in 2 or 3 stages. You don't need to worry about that, but your response has to be coherent and logical. If it's not coherent and it doesn't follow through properly, people can't understand it, you're not going to get the maximum marks. Okay, and so that's why you need to make sure whatever you write, it needs to sort of follow through. It's logically following through. Otherwise, you will not be able to get full marks. I think they penalize you by 1 mark. Okay, so let's see how would I approach this question. The first thing I need to do is I need to make sure. So the acid that I use must be. I got to make sure that it's an excess. Okay, because I need some of it to remain unreacted. Yeah, so I need some of this to remain unreacted, so then I can titrate it with something else. Okay, so how much of the acid do I have? Okay, I have this much acid. So the first thing I need to do is make sure the examiner is aware that I need excess acid. So need excess acid. And in order for me to work that out, I need to know, well, how much acid do I have in the first place? So I need to know is moles of the acid. Now, the 2 equations that you will be using sort of often in chemistry, yeah, is these 2. So it's the in terms of solution titration, what you need is moles equals CV over 1,000. So that's the first equation, and the second equation that you'll need is number of moles equals mass over mR. And as you will see, I will be using both of these equations. Yeah, these are your bread and butter equations. Yeah, learn how to use them. This is, as I say, this is a year 1, amount of substance, etc. type topic. Okay, so you will need to know these, learn how to rearrange them, etc., etc. Anyway, going back to the question. Okay, so it needs excess acid, and you need to make sure that you highlight the fact that you need excess acid. Okay, but then work out how much acid. Now, if I were you, I would actually start using sort of chemistry terminology. I keep saying that, right? So even in sort of abbreviations, so N, right? So NHCl, right? So that just means moles of HCl. Okay, and how would I work that out? Well, I know the equation is CV over 1,000. Okay, so I'm going to literally use the data from here, CV over 1,000. So of course it's 50. Some of you do remember this equation as CV, yeah, concentration times volume. But remember, if the concentration is decimeters cubed, then fine, CV is fine. But often in chemistry, in a lab, etc., you're measuring in centimeters cubed, right? So that's why I remember it this way. So CV over 1,000. Okay, so 50 times 0.2 molar. Yes, it's 3 decimal places. Okay, but I am aware of it, but I'm not going to write it down just to speed things up. And then, of course, divided by 1,000. I'll think about this precision, obviously, near the end of the answer if I need to. Okay, right. So the answer to that is moles of HCl, 50 times 0.2. So the answer to that is 0.01 moles. So that means the moles of the acid that I have is 0.01 moles, and therefore the moles of the calcium hydroxide that I need must be less than half of that, because the ratio of HCl to calcium hydroxide is 2 to 1. So if I've got 0.01 moles of HCl, therefore I need 0.005 moles of calcium hydroxide. So therefore moles of calcium hydroxide that I needed is less than, okay, not less than or equal to, yeah, less than 0.005. Where did I get this from? Well, literally 0.01 divided by 2. Yeah, so half, isn't it? Yeah. So I need 0.005, or in a standard form is 5 times 10 to the minus 3 moles. You don't need to write both, but anyway. Yeah, so that's the number of, so that's the moles of calcium hydroxide I need to react with the acid that they've given me. Okay, it can't be more than this. Right, remember, in the equation, they react 2 to 1. So if I have 0.01 mole of this and I have 0.005 of this, they both will just neutralize each other. They will just react completely and neutralize each other. I will not have any excess HCl left, and therefore I will not have any to titrate with my back titration. Okay, so I need this to be 0.005 moles or less. Okay, so now that's fair enough in terms of moles, but what about in terms of grams? Because they've given me sort of a solid. Okay, so now I need to find out, well, all right, 0.005 moles, how many is that in grams? And so I need to change that now into grams. And of course, that's where this equation will come in. Okay, so I need mass equals Mr. Moles. So therefore, MR is, MR of that, you can work it out, okay, 74.1 times by, and moles, yes, that, which is what I need. What mass does that give me? It gives me 0.3705. Now, I will not be weighing 0.3705 grams, okay? Because as I said, remember, that will then completely neutralize the acid that I have. So what I'll need is, I'm just going to use, I'm just going to use slightly less, okay? So 0.37 grams. That means that I'm using less than the half, okay, less than half of the calcium hydroxide. Okay, yeah, not up by a lot, but it's still less than. Okay, okay, so that's 0.37 grams. So that is the mass of calcium hydroxide that I need to react with this HCl. Okay, so far as it stands, this is how much calcium hydroxide do I need. Okay, and of course, this is how much sort of acid I'll need. Okay, next stage, so next step, I suppose, the method. I now need to explain how will I carry out this titration. Okay, and so you've got to have some sort of key points here. Okay, so what I'll need is 50 centimeters cubed. Remember, they're giving me 50, so this is now the method. Okay, I will need to use the pipette, and you can write down full sentences if you want, but I'm going to write down abbreviations. Yeah, so 50 centimeters cubed of the HCl, because remember that's what they're given me, 50 centimeters cubed of HCl. I will need to use a pipette. So pipette this out into a conical flask. Now to that conical flask, I will then need to add the 0.37 grams of calcium hydroxide. So add 0.37 grams of calcium hydroxide. All right, and remember now, as soon as you've added these two together, the HCl is reacted with calcium hydroxide, and some of the HCl is remained, because remember this is less than half, yeah, because the equation tells me 2 to 1, right? So that means this reaction's happened, but there's still some excess HCl left. And now what you do is you just take that conical flask and you say, right, in that conical flask, add indicator. You can mention which indicator, it's up to you. Indicator into conical flask. Okay, and then now you need to titrate, and this is where that third chemical comes in, right? So the thing you need to think about is, okay, well, obviously HCl is reacting with calcium hydroxide. Now, what other thing does HCl react with? Well, it's an acid, right? So what does an acid usually react with? It's an alkali. So the common alkali, don't start going with out of these, weird and wonderful stuff, yeah? Just use things that you know. So for example, HCl, okay, it reacts with sodium hydroxide, so go with sodium hydroxide. Okay, so you can say, okay, HCl with sodium hydroxide, so titrate this with sodium hydroxide. Now you can't just say sodium hydroxide, you've got to be a little bit specific, so you've got to know the concentration. So you can select a concentration of 0.1 molar sodium hydroxide. Yeah, so at least it'll help you in the rest of the question. Yeah, so it's better if you select a concentration, and of course you do need to know the concentration of whatever you're titrating with. Okay, so titrate it with 0.1 molar sodium hydroxide, and of course, remember, we're still talking about the method. Record the volume. So record the volume of sodium hydroxide when, or at color change. Yeah, maybe I should put just at color change. So end point, isn't it? Okay, and then I'd go sort of a step further. I'll say, okay, well, I've got the volume. Now what do I do? Well, now using the concentration that you know and the volume that you just found out, I'll work out the moles of sodium hydroxide, okay, that were needed. Okay, so moles of sodium hydroxide equals, right, and literally I'll say volume, because I don't know what the volume is, because remember, I'm just telling them how you'd carry this out. I didn't actually do it. So volume times 0.1, so CV over 1,000. Okay, and that gives you moles of sodium hydroxide that you used. You know that I'm just going to restart it here. The moles of sodium hydroxide is volume from titration times by 0.1 molar, because that's the concentration you decided you're going to use, and divided by 1,000. But the question is, that's the moles of sodium hydroxide. So that means how much moles of HCl were there? And of course, you know that the HCl react with sodium hydroxide as according to the following equation. And you know they react 1-to-1 when you balance it. Okay, so if they react 1-to-1, okay, and you just found out that the volume of sodium hydroxide is that means the volume of HCl will be the same thing. And so therefore, I'm going to, it's always good to annotate your calculations. So since these react 1-to-1, therefore, okay, moles of HCl equals, remember, I don't actually have a value number. I've just got that expression, so I'm going to have to use that expression. 0.1 divided by 1,000. There. That's the moles of HCl present. So this is the moles of HCl present in the titration. Okay, that's the titration that you did. Okay. Right. Now remember your original question. Right? Your whole reaction was this initially, what you've just titrated, so this number here, so this moles here, is the extra that was left after it reacted with calcium hydroxide. That means you've got to say that moles of HCl, so I'm going to say excess. So this was what's left. And therefore, moles that must have reacted, so the moles of the acid that must have reacted. Now remember, we had, how much moles of the acid did we start with? We had, and I'm just going to show you here, moles of the acid that we had at the start was 0.01 moles, right? And after the reaction, if this is what's left, so therefore, how much acid must have reacted with calcium hydroxide? So, moles of acid reacted with calcium hydroxide must be equal to 0.01, which we started with, minus this excess, this what we just found out. So I'm going to have to put expression, remember I don't have actual values, right? Times by 0.1 divided by 1,000. So number of moles of HCl reacted with calcium hydroxide must be that minus what we started with, minus whatever's left at the end. Yeah, the rest must have reacted with calcium hydroxide. Now, that's the moles of HCl reacted. Now, going back to the equation, the moles of acid that's reacted is that much. And according to the equation, whatever the moles of HCl is reacted, the calcium hydroxide is half that. So it's 2-to-1. So therefore, moles of calcium hydroxide that must have been present must be, watch this, 0.01 times by 0.01 divided by 1,000 divided by 2. Since calcium hydroxide to HCl, so the ratio of the reaction is 2-to-1. Okay, and that's why maybe I should have put that here. Since that, therefore, and according to the equation, and therefore, the moles of calcium hydroxide that I must have had, in that original mass that I weighed, 0.37 grams, it must be that many moles. Coming back to the equation, calculate accurately the relative. So how would you calculate accurately? So remember, they want you to work out the relative formula mass. Okay, well, you've got the moles of the calcium hydroxide. Okay, and you had right at the start when you weighed it the mass of the calcium hydroxide. So of course you just use MR equals mass over moles. So mass over moles of what? Mass over moles of calcium hydroxide. Now, if I wanted to, that's the moles of calcium hydroxide. I could have just put all of that expression underneath here. Yeah, so M over all of that expression. But I think I've said moles of calcium hydroxide is there. I've said moles of calcium hydroxide. Yeah, and therefore I think that should be fine. But if you wanted to, you could have put all of that expression just underneath there. Yeah, so it's MR equals mass over whatever, and that would have given you the MR. This is sort of a long question, right? Lots of writing. However, look, you're bound to get these eight mark questions, yeah, extended questions. This is the new syllabus, okay? But all I can say is you need to practice more, and whenever you're looking for these kind of questions, look for sort of back titration type questions, yeah? Search for them and practice them. Marking, in terms of marking, what you'll probably get is, so they'll have, I mean, the marks probably will be saying the fact that there is, the acid needs to be excess. Then you need to work out the mass of the calcium hydroxide that you're going to have to weigh, the moles of the acid that you're going to be using. So there's going to be that, the sort of the moles of the calcium hydroxide, yeah, that you need to start with, and then of course in terms of the method, yeah, you're going to have to say, I think that's going to be a mark, the fact that you're going to react these two, HCl and the calcium hydroxide together in a flask. Indicator, etc. Then you're going to have to use indicator and then titrate it with a known. I think that's going to be a mark. So that's going to be a mark. And then the second part of the calculation, so your stage 3 or whatever you want to call it. Okay, so all of that is going to be a mark. I know it seems a lot of writing for 1 mark, but it only seems a lot because of the sort of expression that you have to keep having to carry forward. Otherwise, if it was just a number, it wouldn't be such a long calculation. So 1 mark, and then the last one is to actually find out the MR. So 1 mark, so that's 8 marks. Okay, now this is the classic question, yeah, where I can't say this enough. You think, okay, you know this, yeah, now you know how to do it because you've seen me. My suggestion is, don't go through this, yeah, don't listen to me, try this question, yeah, by yourself, yeah, and trying to get to the answer. The only reason this question seems a little bit more complicated is because, remember, there's no actual values, okay, so you're trying to carry out expressions all the way through in terms of calculations, and plus they're assessing you on the method as well. Back titrations, if you do want to do a lot of calculations on this kind of question, my suggestion is get a textbook. There's a textbook called Calculations in A-Level Chemistry. Okay, it's a really good textbook. I can't remember the name, but I will put it up somewhere here. Yeah, somewhere. It's by the same guy who writes the website called Chem Guide. Okay, it's very verbose. It's like lots of words in the actual website, but the calculations book. Textbook is very good with lots of examples, but also lots of practice questions as well. Okay, or you can search for these kind of back titration questions on the internet. Okay, so try these questions, and again, if there's another question that you want me to go through, let me know, please. Yeah, and I'll go through it. I'll see you next Tuesday. Bye.